5, 4, 3, 2, 1, 0. All engine running. Liftoff.
Hey everyone, welcome to another episode of the Space Business Podcast, where we investigate all the exciting ways in which people participate in the new space economy by conversations with entrepreneurs, executives, investors, and other members of the space family. I'm Raphael Rodkin, and I'm an investor in and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. Sadly, I am not a rocket scientist, but I am an alumnus of the International Space University, which is also our partner in the podcast. Here's a short message from them.
The International Space University, founded in 1987 in Massachusetts, USA, and now headquartered in Strasbourg, France, is the world's premier international space education institution. It is supported by major space agencies and aerospace organizations. ISU offers the Master of Science in Space Studies program at its central campus in Strasbourg. ISU also conducts the highly acclaimed 2-month Space Studies program at different host institutions in locations spanning the globe, and more recently implemented the Executive Space Course, the Southern Hemisphere Space Studies program, and Commercial Space program. ISU programs are delivered by over 100 ISU faculty members in concert with invited industry and agency experts from institutions around the world. Since its founding, 33 years ago, more than 4,800 students and participants from over 100 countries graduated from ISU. Follow us on social media at ISUNet.
Our guest on this episode is Matt Desch, the CEO of publicly listed satellite communications company Iridium. There's clearly a lot of excitement about low Earth orbit-based satellite communications networks these days, like SpaceX's Starlink, Amazon's Kuiper, or, until recently, OneWeb. But if you are old enough to remember, there was a lot of excitement about the same thing more than 20 years ago. The companies at that time, names like Iridium, Globalstar, Teledesic and others, invested billions and in the end either shut down or had to restructure. I met Matt at a Satellite 2020 conference in Washington, D.C. The keynote speaker at that conference was Elon Musk. When asked what his own objectives were for his Starlink communications network, he said something along the lines of that it would be nice to at least not go bankrupt. Back in the 1990s, Iridium did financially restructure, but it re-emerged and today successfully operates a constellation of 66 low Earth orbit satellites, providing communication services to government, corporate and private customers. Matt has been the company's CEO since 2006. That is around the same time when Elon tried to launch the Falcon 1 for the first time. And he has been in the telecommunications sector since the late 1980s. So he has seen a lot, including, by the way, an in-orbit crash of one of the Iridium satellites. So we touch upon the topic of space debris as well. For all these reasons, you will definitely want to listen to Matt's views. So without further ado, please enjoy my conversation with Matt Desch. Cool, so we're here with Matt Desch, the CEO of Iridium. We're at Satellite 2020, which is happening despite the coronavirus. There's a lot of elbow greetings going on. We're using more hand sanitizer than ever in history before, I think. So welcome, Matt. Matt, it seems like in satellite communications, we're partying like it's 1999. Everybody's aware of the big constellations like Starlink, OneWeb, and Kuiper, and obviously you guys have been around longer than all of them and have more experience than all of them. Can you elaborate a little bit how you see the new players fitting in with some of the more established players like yourselves?
Yeah, so first it's important to understand that while everyone has finally figured out that LEO, low Earth orbit, is the best place to be, due to latency and coverage and a lot of other factors. That's what we were 20 years ago. They're all using a very different frequency and have different business plans than we do. So we were L-band and we're focused more on personal communication services, starting with a satellite phone and moving through IoT and tactical radios and things that really connect to people, small antennas, less bandwidth, but much lower cost, etc. They're all going after kind of what I would call a commodity spaces using KEA and KU band spectrum very similar to what the existing long-standing VSAT, fixed satellite service operators, have been doing for many, many years from geostationary orbit, but only doing it from LEO orbit. So we're complementary to those satellite services, and will be complementary to the new mega constellation. So that's the first thing. In fact, you've even seen us do some partnerships with OneWeb to begin with, and I expect you'll see more in the future as people see to put our solutions together on behalf of maritime or aviation or other customers. That said, what's happening now in this area that I don't know if they're still calling it new space, but people are struggling for what this boom has been over the last 5 years or so. Feels a little bit like the boom that happened in 1993 to 97, in that there's an awful lot of investment, many companies going after the same thing. That's what happened actually when Iridium was formed. I found it interesting listening to Elon Musk yesterday when someone asked him for his vision of Starlink, and he said, "I'm very simple. I just don't want to go bankrupt." And I thought that was a smart answer in the sense that, he called out that Iridium and Globalstar, Orbcomm, and others from the era we came, of all those, only Iridium has really emerged now as a very successful second generation financially mature company that is growing very fast and generating a lot of cash, achieving what it wanted to. These new mega constellations have a lot of questions still ahead of them, and most of them are not fully funded yet. Most of them are still, in fact, in Starlink's case, they're sort of in a big test mode to understand. As Elon said, he's trying to make sure he understands exactly how to make it the right kind of service so he can know that it's worth spending $10 billion before he does. And by the way, that's $10 billion just every 5 to 7 years, to do that. So he's got to really be sure that that's going to have the returns he wants to have it. I think OneWeb is looking for additional funding, and Telesat is still looking to get started, and so everybody's in different states there. It's exciting, the potential for them, but it's also a little scary in the sense that if any of them start having problems, or the kind of problems we had in our first generation, that could cast the same pall over the industry that Iridium did back in 1999. Now, hopefully, they'll all come through that and achieve the success that Iridium had, but it took Iridium 30 years to get to that state. And it's great to be here. It's great to have high cash flow, high growth environment, but they need patient capital to be successful. So they need to make sure that that they're not promising returns too quickly, because it's always going to take longer in space and be more difficult than you ever expect.
Besides the funding, are there any other particular issues you think that are maybe underestimated? I'm thinking about anything from obtaining landing rights to like certain technological issues like antennas and things like that.
All those are big issues.
All of the above.
I will say that the biggest issue that going back to the first broadband low Earth orbiting system was a company called Teledesic back in the 90s by Craig McCaw and Bill Gates and others who invested in that. It also went bankrupt, and its main problem, if you ask any person from Teledesic, was the terminal, the end user terminal. Can it be low enough cost and effective enough that it could be sold to compete with other terrestrial options, because that's what it will ultimately do. People have talked in the past about the magical $100, $200 broadband terminal, but unfortunately that is still years away at best. So I think that's one of their key issues. Regulatory issues continue to be an issue for many of them, particularly landing rights, particularly security issues. They all have technical issues, but I think they're all achievable. I'd say the biggest one is really just the business case. And it's not just raising money, but it's actually delivering the return on capital that investors want to achieve, and assuring themselves that they can do that, and as Elon said, not go bankrupt.
Now, you've spoken very favorably about LEO, and that's obviously the current wave of these constellations. Now, there are unnamed competitors who may start with the letter V who are talking down LEO a lot, citing things like you spend a lot of time over water, you need very large constellations. How would you respond to some of those concerns?
Yeah, and obviously you're referring to Viasat because they've staked their claim in geostationary. And I'll be honest, I believe they have a good point. I don't believe there's anything that magical about LEO. I would love to tell you that it's all about LEO, and that will create success. You can have success from geostationary orbit as well. And if they can achieve the objectives that they've set out with their Viasat 2 and 3 and eventually 4, it sounds like they're already talking about, then they can supply the capacity and cost for a commodity broadband service that people need. There will be applications that are really low latency that they won't be able to support as well, but I don't believe that's the primary issue. I will tell you, though, Iridium's view on all this is that this is why we have avoided the commodity broadband space. It is too many companies coming with too many solutions, and you haven't even brought into play Google Loon and Facebook Aquila and HAPS solutions, high altitude platform systems. I can't remember what they're exactly called. And there's many, many ways of bringing a commodity broadband internet connection to people, and it's only going to create lower and lower costs, which as a consumer you should be excited about. But if you're going to produce a lot of capital to create that, and then people can't pay high prices and your terminal has to be subsidized or it's too expensive, then it's going to be challenging in terms of the future.
So do you think we might run the same risk here as what happened terrestrially with the fiber networks around the turn of the millennium? Like, people like WorldCom and Global Crossing who went bankrupt in a fiber glut?
Yeah, well, I was there. I was a supplier to those companies. And our pitch, of course, was no, the internet is going to go on forever and pet.com and going to take over our world. And we were right. We were about 25 years too early. But no, I ran Nortel's Europe and Asian business at the turn of the century there, and we were building something like 25 to 30 redundant fiber systems around Europe to do the same thing. And of course, each one of them said, we'll need all of them. Unfortunately, it finally happened. Worst case scenario happened. We didn't need hardly any of them. So it took many years before we eventually used up that capacity. I wouldn't say that there's an absolute direct comparison here, because investors are being careful right now. While there are a lot of planned ideas, there hasn't been that much funding, and there are some of the new carriers have unique situations. You can see how Amazon has businesses that it could take advantage of off the bat if it's successful. Both Amazon and SpaceX, and particularly SpaceX, have launch platforms and can possibly subsidize something that typically costs, in our case, it costs 30% of the total cost of our build. If you can reduce the cost of that, perhaps you can lower the overall capital cost. So there may be differences this time around that make these companies successful.
You're mentioning a very important point that, so if you talk about the commoditized end of the business, and if one simplistically looks at, the production cost, something like, dollar per gigabyte, and maybe that is too simplistic, and you can tell me, can anybody actually beat SpaceX given the vertically integrated launch capability?
I don't know. I mean, honestly, you're right. I think that's their strategy. If you can bring the most capacity to bear over a spot, you can possibly lower the costs to the lowest of anybody and therefore pick up the business. But I don't know how low that will have to be. And or if they can make the service so straightforward, easy to use with so little cost associated with it that they can generate the return on capital that will require to get to that point. That's the big question right now in the industry. Frankly, it's kind of exciting to watch. I'm rooting for them. I really want them to succeed. It's just we've lived for 30 years in this environment to know how difficult it is to create a viable business, which is why, again, I'm just happy. I think Elon Musk and others have their eyes wide open, but it's why they're all not recklessly just throwing lots and lots of dollars at this to see who can be the first to be there. I think they're all really working hard to create a service that will work and are trying to get the value proposition correct, and I'm really, really hopeful they'll be able to.
Changing tack slightly, one important product for you guys at Iridium is IoT, Internet of Things. Now that's yet another sub-segment where we're actually seeing a lot of new entrants in different parts of the sub-segment. In my daily life as an investor, I get approached by companies like Swarm, Fleet, Mariota, Lacuna Space, and probably a number of others that I'm forgetting now, some of which are now raising quite large sums of money at quite large valuations. So similar question as before with the broadband guys. How do you see them all fitting together, and also where do you guys fit in?
So I thank Motorola when they created us to have created our basic architecture, which started out being satellite phones, but today the majority of our business is IoT. And in fact, I kind of see ourselves as optimized for IoT. And when I say IoT, I mean a direct from satellite to device solution that is very low latency, very high quality, very consistent performance, can be relied upon anywhere in the world to deliver information extremely efficiently. And as a result of that, we have almost 1 million devices on the network. It's growing at 20+% for the last 10 years. We are become the satellite IoT company over the last 6-7 years. Now, there are other kinds of IoT. There is what I would call broadband IoT. That is really what the mega constellations and other companies getting involved in this are doing. They really want to create a very high bandwidth node someplace that distributes IoT in a regional area. And that is a viable way. It's a smaller market in the IoT space, but one in which they would all say that's the kind of IoT they're providing. Starlink, OneWeb, et cetera, will provide that service. They cannot create the kind of IoT we do. They cannot scale down to a very low-cost antenna, small battery-powered. It's just not their architecture, nor do they plan to do that. Now, you just mentioned the third kind of IoT companies from space, which I would call narrowband IoT. Those are all what I call high latency companies. That is not real time, so very rarely two-way. Mostly they are for very low power devices, typically battery powered, that could live in a field for 5, 6, 7 years at a time, waking up to send maybe one data point a day that would be delivered sometimes within 10 minutes, sometimes within several hours. And I believe, the ARPUs, where our ARPUs say might be $10 a month, the ARPUs for a broadband system might be $1,000 a month for that one node, hopefully distributed up amongst many, many regional customers. The ARPUs typically these guys are looking at are like 25 cents a month. So it's a completely different business and different model.
Yeah, it seems to be it's typically about 1 cent a message, and like you said, you don't need to send a typical message very often.
Yeah, if you need the how much moisture is in this field, and you want each field has a different moisture container, you don't need to know exactly what moment in time that moisture reading was. You just need to know sometime during the day that was a fairly dry field, so you can decide to turn the water on. And there'll be lots and lots of those devices, and I think those networks are being built. Now, that being said, there's an awful lot of those networks being built. Again, there seems to be a gold rush, and I think I can count at least 20 companies. Most of them are not they're certainly not the kinds of investment that you see from OneWeb and Starlink and those kind of companies. They're more in the tens or hundreds of millions instead of the billions of dollars, but they still all have to compete with each other, and we've met with many of them. We have a number of relationships. We think their businesses are very complementary to ours, and think, frankly, they can do things that we wouldn't want to do with our network anyway. But instead of building that ourselves, or we could certainly launch a network like that, I think there's plenty of being built today. I'd rather see who the winners and losers are and help them, and possibly introduce the right ones to our 450 IoT partners today at the right time and place. And we might be the best channel for their services, or might be a technical partner down the road, or who knows, maybe even an acquirer.
Strategic investor. Interesting. How important in IoT is the 5G integration?
5G has 3 main components. It has faster speeds to cellular phones. That's what we're seeing right now. It has an extremely low latency component, which is connected cars on highways, highly dense environments. That's something in the future. And then the third version of it is this IoT capability, which provides it. In almost all 3 of those cases, it still only works on 10 to 12% of the planet's surface. 5G isn't about expanding the footprint of cellular. It's about actually densifying it and making it more efficient where it is. Our business is always, it was originally built to kind of compete with cellular, but we've realized 20 years ago that wasn't the right place to be. We wanted to be complementary to cellular. So in all of our IoT applications, they are almost all IoT applications. Typically, there is a 3G, 4G modem already on there, along with our satellite modem. And the application, whether it's a piece of heavy equipment or a transportation or sometimes even a container tracking device, uses the really low-cost cellular if it's available. But these are often applications that go out of cellular coverage and they use us. Mm-hmm. I think as 5G emerges in that, we'll be a complement to 5G modems, and we will supplement those to give them access to the other 90% of the planet that they don't cover. That will always will always be the best solution in a part of the world that cellular, whatever G it is, doesn't cover.
Mm-hmm. We've already touched upon some of the technological changes and exciting developments that are going on currently, for example, with antennas. Quickly want to talk about your satellites as well. I think you completed your constellation last year, if I'm not mistaken. You have, I think, 75 satellites, including the spares up there right now. Just to remind ourselves, what is the lifetime of those satellites, and do you see significant changes in the next generation when you get to replace them?
Yeah, so yes, we did just complete a $3 billion network upgrade. By the way, it was a completely seamless upgrade. Our customers didn't even know as we transitioned from our first generation network to our second generation network. We did it without dropping a packet or a voice call. We've deorbited all the old satellites and they've all burned up in the atmosphere. So a pretty amazing technical achievement to get to that point. And believe me, it's really fun not to have to spend $3 billion again and actually be able to generate cash instead of spend it. As far as each of those satellites has been built, unlike the current sort of new space concept where you build lower cost, cheaper satellites that have a 3 to 7 year kind of life cycle, our satellites were built to much higher quality standards, so they really are more like 15 to 20 year kind of constellations. The satellites were built to a 12-year design life, and you expect to get, with spares and everything, 15 to 20 years life out of them, like we did with the first generation constellation. So a long life. That's why we're very unique in the satellite industry in that we have a 10-year CapEx holiday where we are going to spend an average of $35 million a year, which is very small compared to our profit and earnings. So we're really going to be able to generate a lot of cash for the first time in many, many years. And so that gives us a lot of time to think about the next generation. We have a lot of capacity in our existing system, so we can supply a lot more service with what we have today. I'm expecting that the next time around when we do this, and we're debating on what the name of that will be, it probably won't be Iridium Next or Next Squared. Somebody was lobbying me at the conference today that it should be called Iridium Beyond. I like that, but if I have to pay royalties, I'm not going to use it. Yeah. When we do that, I'm really not sure that it will even be a complete new constellation, or whether we might be a payload on another constellation, or our L-band service might be a multi-mode service with other capabilities. And I'm not even sure it would necessarily be commodity broadband. It could be other applications in space. For example, when we launched this Iridium Next constellation that we just completed, we had a hosted payload on each one that tracked aircraft in flight. It was a joint venture we created with the FAA equivalents of Canada, the UK, Ireland, Denmark, and Italy. And it's called Aireon, A-I-R-E-O-N.
Sure.
And Aireon is a payload that listens to every aircraft, say where it is, what altitude, and it transfers that information to an air traffic controller. So the world that had only been like 30% covered by radar now is 100% covered by the system that tells you exactly where aircraft are, letting them be very efficient. That service alone is going to be almost as valuable as Iridium is, ultimately, even though it doesn't do anything related to what our communication services are. So I could see doing the next generation system in a completely hybrid fashion with other services in space with our system. So just rebuilding what we have today, I don't think is where we'll be. I'm fortunate we don't have to really broach that subject for a number of years, though I'm sure we'll get plenty of people who want to partner or give us ideas about what that will look like, and we're excited to talk to them about that as well. But for now, we have so many capabilities we can exploit from our current constellation as we move into this new broadband capability, which we call Certus, as we miniaturize the devices that will allow you to take pictures from very small devices anywhere on the planet, to protecting the GPS infrastructure, which are many other topics we could go into, but we have a lot of runway for continued growth.
Mm-hmm. So I want to pick up on something you mentioned, that you successfully deorbited all of your old satellites, which brings up the very important topics of the dangers of space debris. And you are possibly one of the only people, if not the only person in the world, who has very direct experience with the dangers of space debris, as one of the Iridium satellite collided with I think it was a defunct Russian spy satellite or something like that. How do you see space debris? How you guys are thinking about it? What do you think should be done that's not being done?
Sure. Well, back in the 90s when we were created, launching 90 satellites freaked out everybody. It was viewed as extraordinary number of satellites given how many satellites had been. And so the U.S. government, in licensing the original system, asked that we would dispose of the satellites when the time came for it in a 1-year time frame. And in fact, there were no regulations at the time. There were no guidelines. Subsequently, a 25-year guideline was imposed back in the 2000s, but we really maintained enough fuel, et cetera, to deorbit within 1 year. Now, of course, 95 satellites sounds like a slacker, with tens of thousands of satellites. So certainly the concerns have gone up, though. When we launched our new satellites and didn't need our old satellites, we very responsibly removed them from orbit. We lowered their altitude and let them burn up in the atmosphere. And in fact, with a 1-year target, we actually achieved a 1-month target for each satellite. So we far exceeded the expectations that the world had. So we've been a very responsible users of low Earth orbit so far. You're right, it was informed by the fateful day in 2009 when I got a call saying that one of our satellites had blinked out over Siberia, and they don't know why. And you need to know the environment back then. We were not getting precise information about space debris. In fact, the information that was in what was called the space catalog was dithered in a way that we couldn't know exactly where things were because it was viewed as a strategic information. Because of the collision, those who maintain that database realized it made no sense to do that any longer, and that precise information about debris was supplied to us and all the other operators. As a result of that, we have been moving satellites where we never did before. We wouldn't have moved them before because we were worried we'd move into trouble as easily as moving out of trouble when the error bars that they were telling us about was up to 1 kilometer. Which direction are we really supposed to move? Now we have very precise information. We have a very close relationship with people that maintain the information about space debris, and as a result of that, we have a defined regimen that makes us move satellites up to about once a week on an average.
Is that the data from NORAD, or what are you using?
Yes, it's from what's called the Combined Space Operations Center in Vandenberg Air Force Base, and a very close, something called the Commercial Integration Cell, along with many other satellite operators, now are embedded in that and share lots of information about our satellite position. So we take space sustainment very seriously. We worry about anyone who flies above the space station without thrusters, without information, without being part of the information transfer. We worry about anybody who doesn't design a lot of redundancies into their satellite systems, because this is a shared resource that we all share. And it's important to know that if for some reason your satellite should die in space, even at our low altitude, which is only 780 kilometers above the Earth, it's 100 years before the satellite decays. At OneWeb's orbit, which is up at 1,100 kilometers, it's 1,000 years. So that's a long, long time for something that's out of control to possibly collect, to hit other things, right? And that we just can't survive as an industry. So I'm I'm encouraged about what both the new constellation players like OneWeb and SpaceX are doing. I'm encouraged by all the efforts that everyone in the industry is doing to be as responsible as they can be. I worry a little bit that it's all best efforts. It is all best practices. There is no regulation still requiring practices, and there will be satellite operators in the future who may not follow the best practices, and if they don't, it won't just hurt them, it will hurt the rest of us too. So I believe the environment in space today is safe, but we do want to keep it that way. And safe is a term I use carefully. I mean, we can manage the current risks that we have today, but with the coming launches of thousands of satellites, we have to be very, very careful not to change that environment to something that would become untenable for all of us.
Because I suppose if you look at some of the historical failure rates, and I know, of course, satellite technology has advanced a lot, but even if it's just 5% on 20,000 satellites gets you to very frightening numbers of potentially defunct satellites, which is why people are proposing the potential cleanup mechanisms. But I suppose, which then brings up the questions, who will pay for these?
So that's a real problem. And I got into sort of a Twitter exchange about this factor with some of the people in the industry who were interested in these things, and they said, what would you pay? And I threw out a thought experiment to say, you have to understand, I mean, if one of, and I, by the way, you said 5%. We had a much higher failure rate than
historically,
that in the first
generation.
Yes. And so 5% would be
great.
Good.
Yes.
Now, I don't believe we're going to have that going forward, but let's just say we did. So people said, well, wouldn't you like to bring some of those old ones out of space? Well, first of all, that was from the bankrupt company. I don't know if I'm not sure if I have, I think I have moral responsibility for those, but I'm not sure I have legal or financial responsibility for those. But let's just say I really want to get those out for some reason. They, by the way, are below my network. They're not going to be any harm to me. So I wonder what the business case is for my shareholders for me to spend money on bringing those out. Now, I think it would demonstrate good leadership to the industry to do it. So I'd be willing to spend something. I think it's good public relations. So I'm certainly interested in doing that. But when I understand that the best price they can do would be millions of dollars for even one piece.
Correct.
And remember, there are potentially 100,000 pieces of debris up there. What would you spend to just get one out? I think you'd spend very little. So I threw out $10,000 just as a thought experiment. Of course, that was immediately quoted by space writers that Matt Desch is looking for a $10,000 solution. Okay, I guess that was a mistake. But
it was on Twitter.
Yeah, it was only on Twitter. I was just engaging with some people in a thought experiment. But it does beg the question: what will be the business case for these? Now, I'm hoping that those systems develop. I'm hoping they come down in cost, but I'm afraid we're going to need a completely different way of funding them and creating them. And it's probably going to be a global problem that all the countries of the world have to get together, because I don't know that any one operator or any one entity will ever be able to afford to make a dent in the problem without that.
No, agreed, and I suppose that's why people are talking about almost like taxes on launches and business models, revenue models like that. Matt, I want to just finish up on a very simple question. Is there anything that you think that the people following the companies, the investors, the analysts are over-focused or under-focused on, or even misunderstanding about Iridium?
Well, there's a few. I mean, and some of it just come from the history and the fact that we're in an orbit that everyone is using, and a lot of people assume that every time they hear of a new launch into LEO, that means that whatever else is in LEO is competing with it. So as we talked about, I think I need to patent the phrase. It should be on a T-shirt. That low Earth orbit, or LEO, is a neighborhood in space, not a business model, is what we basically say. Just because we're along this line doesn't mean we're doing the same thing based on our frequency and our business focus. We really are doing very different things. So that's the first one, and I think that's been understood now. The other is that Iridium is like any other satellite company still, or that any of the other satellite companies today are even trying to do what we've done. I mean, we really are excited that the lane we've chosen is a very important one, an interesting one, and it appears to be a pretty clear lane in terms of not many people have come to try to tackle that lane. So personal communications to very small devices and that can be used by consumers and the Internet of Things is really, frankly, an excellent space that we have a really clear runway. So we're now in sort of a financial phase of our development. I think that a lot of people are surprised at our success and all the cash flow we're generating, and they're acting like we're an overnight success story, when in fact, of course, it's only taken us 30 years to get to this overnight success. But it's a lot of hard work, and it's a lot of risk that we had to retire over many, many years to get here. So, but they need to know that risk is behind us for the most part. We have a clear runway and a lot of exciting growth, and I'm expecting that investors will evaluate us and value us accordingly.
And I hope you and the investors are going to reap the cash rewards over the next few years.
That is our commitment.
Thank you very much, Matt.
Really good to talk to you. Thanks.
That's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can also follow us on Twitter at podcast_space. Also consider supporting the podcast at www.patreon.com/Space Business Podcast. If you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or are interested in being a sponsor, or really anything else, drop us an email at spacebusinesspodcast@gmail.com. That's it. I look forward to seeing you for the next episode.